Next problem is find the volume of tetrahedron bounded by the coordinate planes and the plane x plus y plus z is equal to 1. So this is the plane x plus y plus z is equal to 1. And we have this tetrahedron, figure tetrahedron. And we have to find its volume. So uh, in the same manner, we will find the volume like this, the area of the ellipse. So how we can find the area of ellipse? So problem of area. So this is the problem of area. That is, find the value of x. Then find the value of x from the given equation. Two values are lower limit and upper limit. And if you have one value, then lower limit is 0. And if find substitute x as 0 and find value of y. So if the equation is in terms of x, y, z, then find the value of first x, then substitute x as 0, find the value of y, and then substitute x and y both are 0 and find the value of y. So here is the procedure of that to find the volume of the tetrahedron. So the given equation is this. So from this we find the value of z first. So z is what? 1 minus x minus y, and the lower limit is 0 because the tetrahedron bounded by the coordinate planes. So x is 0, lower limit is 0, and z is what this. Then substitute z as 0 and find the value of y. Y is what? 1 minus x. So, and the lower limit is 0. And then substitute y and z both are 0. Therefore, x is 1 is the upper limit and x is greater than or equal to 0 is the lower limit. Okay. Or instead of this process, we can also apply. First, find the value of x, that is 1 minus y minus z, as its upper limit and lower limit is 0. Then substitute x as 0 and find the value of y, that is 1 minus z is the upper limit and lower limit is 0. And then substitute x and y are 0, then z limit of z is what? Z is 1, therefore 1 is upper limit and lower limit is 0. So either apply this procedure or the another procedure. Okay. And then the volume of the tetrahedron is triple integration over v dx dy dz. Integrate 1 with respect to x, y, z. Okay. So integration of 1 is the value. Integration of 1 dx dy dz, and integration of 1 dx dy is the area. So z runs from 1 to 0 to 1 minus x minus y. Y runs from 0 to 1 minus x, and x runs from 0 to 1. So right. The order of the z is first. So write z because the limit of z is in two terms, in two variables. Limit of z is in two variables. The limit of y is in one variable, though its sequence is second. And lastly, we integrate with respect to x. So dz dy dx. So integration of 1 is z from 0 to 1 minus x. Then value at the upper limit is this. Value at the lower limit, that is equal to z. Substitute z as 0, we have the 0 answer. Okay. And then it's integration with respect to y, 1y. Then x is constant, x into y is its integration. And integration of y is y square by 2, 0 to 1 minus x. Then value at the upper limit, that is substitute y as 1 minus x. We have this answer. And substitute y as 0, we have answer 0. So minus, right, minus 0, or delete that minus 0. And then its limit is what? Either simplify this bracket or directly use rule a minus b x, or ax plus b, ax plus b. The integration of ax plus b is what? Ax plus b raised to n is what? Ax plus b raised to n plus 1 divided by n plus 1. Therefore, this is the factor of the type ax plus b. Ax plus b. A is 1, minus 1, b is 1. So it's 1 plus 1, 2 power divided by 2, and then right, divide by minus 1. Divide by minus 1. Here, right, divide by minus 1. Its simplification is this, and then its integration is this. So 1 minus x bracket square is simplification of this. So 1 minus x bracket square, 1 minus x bracket square, its simplification is what? 1 minus x, take as 1 minus x as common. So we have 1 minus x in bracket. So 1 minus x bracket square, and minus 1 half, 1 minus x bracket square. 1 minus 1 half becomes 1 half, 1 minus x bracket square. And so its integration is by using rule ax plus b raised to n is ax plus b raised to n plus 1, that is 2 plus 1 is 3, divided by 3 and divided by minus 1. Divided by minus 1 because the coefficient of x is minus 1. And so minus 6 becomes, and then minus the value at the upper limit is 0 because if you substitute x as 1, 1 minus 1 is 0. And the value at the upper limit is 0 minus value at the lower limit is what? 1 minus 0 divided by minus 6, that is minus 6 is already uh, here is minus 1 by 6, so value of this is 0 at upper limit, value of this is at lower limit is 1 cube is 1, so answer is 1 by 6. So next problem, calculate double integration over r fxy dA for fxy is 4 minus y square and x runs from 0 to 3, y runs from 0 to 2. So double integration over r fxy dA is equal to integration 0 to 3, 0 to 2, and this is 1 minus y square. Fxy is 4 minus, here write 4 here instead of this f, write 4 minus y square, and then the limit 0 to 2 is on y, so write dy. 0 to 2, if you write 0 to 2 in second place, then write dy first, and 0 to 3 as dx. All right, here y runs from 0 to 2, x runs from 0 to x is equal to 0 to 3, right? X is there, y is equal to, and then dy dx. That is, we have to integrate with respect to y first. So both the limits are constant, so integrating with respect to y first or integrating with respect to x first, we have the same answer because of the Fabini's theorem. That Fabini's theorem says that state that if the limits are constant, then we integrate with respect to x or y first. Both the answers are same. But if the limits are, the Fabini's strong form is what? The Fabini's theorem strong form is what? If the limits are not constant, then what is the order? That is, integrate if the limit of y is in terms of variable, then integrate y with respect to y first, and if the limit of x are in terms of variable, then integrate with respect to x first. That is the strong form of Fabini's. But if the limits are constant of x and y, then integrate either with respect to x first or with respect to y first. So integration 0 to 3, integration with respect to y is 4, here is 4 integration with respect to y is 4y, and the integration of y is y cube by 3 from 0 to 2, then upper limit value at upper limit, value at lower limit. So substitute x, y as 2 in this bracket, we have 16 by 3 answer, y as 0, we have 0, and then its integration 16 by 3 is constant, its integration is 16 by 3 into x, and the lower limit is 0, upper limit is 3, then 3 minus 0 is the value at upper limit and lower limit, and then for answer with 16. Then we integrate this same example with respect to x first. So write integration now 0 to 2 because limit on y is 0 to and limit on x is 0 to 3, 4 minus y square dx, and then integration of 4 minus y square, now constant quantity, so its integration is with respect to x is x, 4 minus y square is constant, so 4 minus y square integration is 4 minus y square into x, x runs from 0 to 3, then value at the upper limit is 3, value at the lower limit is 0, so that take that 3 as outside the integration, and then 4 minus y square integration is 4y, integration of 4 is 4y, minus y square is y cube by 3, 0 to 2, then value at the upper limit, that is substitute y as 2, we have 16 by 3 answer, y as 0, we have 0 answer, and so again we have the same answer. By reversing the order of integration, we see that the value of the integral remains same, and this is the Fabini's theorem actually. That by reversing the order of integration, we see that the value of integral remains the same. But when if the limits are constants, otherwise if we interchange or reversing the order of integration, then we have the different answer. And that's why the strong form of Fabini's theorem is what? If the limits are limit of y are in terms of variable, then integrate with respect to y first, and if the limit of x are in terms of variable, then integrate with respect to x first. So that is the Fabini's strong form. So again the same problem, same type problem. So integrate with respect to x or y first. So minus 2 to 2 is the limit on y, because here dy dx, that is the sequence is what? First integrate with respect to y, minus 2 to 0 is the limit on y, and 0 to 3 is the limit on x. If I have to integrate this with respect to x first, then interchange these places of integration. That is the integration 0 to 3 right in second place, and write minus 2 to 0 in the first place if I have to integrate with respect to x. So here is the problem. Now x square y integration with respect to y is x square is constant, and integration of y is y square by 2 from y minus 2 to 0. In this way, we have this answer 6, and here we have the answer 6 with respect to x first. So we have the same answer, and therefore Fabini's theorem is verified that if the limits are constants of x and y, then integrate with respect to x first or integrate with respect to y first. Then next problem is evaluate double integration over r sin x by x dA, where r is the triangle in the xy plane bounded by the x-axis, and the line y is equal to x and the line x is equal to 1. So this is y is equal to x line, this is y is equal to x line, this is x is equal to 1 line, x is equal to 1 line, and the x-axis, this is the x-axis, okay? Its equation is y is equal to 0. Equation of x-axis is what? Y is equal to 0. This is y is equal to x and this is x is equal to 1. And we have to integrate over r of sin x by x dA. So over r, integration of sin x by x dA is integration. So now we integrate with respect to x first or integrate with respect to y first. That depend on you. But integration with respect to x first becomes complicated. Integration with respect to x first becomes complicated. So if I have to solve the problem, this problem, then integrate with respect to y first, and so write the limit of y and x. So right here, this step is equal to this step. This step. Don't write this step. That sin x by x dy dx, right? Instead of this dA means dx dy, but write dy first then dx. And so that is, we have to integrate first with respect to y now, suppose. So take strip parallel to y axis. So this strip, this vertical strip is the parallel strip parallel to y axis, because we have to integrate, suppose, with respect to y first, because integration of sin x by x with respect to x becomes complicated. But integration of sin x by x with respect to y is very simple, because sin x by x becomes a constant with respect to y. And then its integration is what? Sin x by x integration is sin x by x into y just. So integration with respect to y first is now simple. So we integrate with respect to y first. So take strip parallel to y axis. And then it's one end of the strip touches to the line y is equal to 0. So we have y is equal to 0 as lower limit. And the another end of the strip touches to the line y is equal to x. So x is the upper limit. So y is equal to 0 to y is equal to x are the lower limit and upper limit. And in order to cover this triangle, we have to move this strip, vertical strip, parallel strip to y axis from this point to this point. And so x runs from 0 to 1. X runs from 0 to 1. And then integration of sin x by x is constant. So y into y just, and y runs from 0 to x. Then value at the upper limit, that is x minus 0, x get cancelled. X minus 0 value at the upper limit. Next step of this step is what? Sin x by x as it is, x minus 0, and then x get cancelled. We have sin x, and integration of sin x is minus cos x from 0 to 1. Value at the upper limit, minus cos 0, minus become plus cos 0, and minus cos 1. 1 minus cos 0 is 1, and minus cos 1. So write value of cos 1 by using calculator, or it remains as it is. And if you have to integrate with respect to x first now, suppose, then what is that? Take strip parallel to x axis, this strip, and then integration over r sin x by x dA is equal to integration. So sin x by x dx dy, right? The sequence dx dy, and so limit of x are what? This strip parallel to x axis touches to the line y is equal to x. So x is equal to y is the lower limit, and the another end of the strip touches to the line x is equal to 1. So x is equal to 1 is the upper limit. And in order to cover this area, we have to move this strip from this point to this point. So at this point to this point, so right here dotted line. So here y is 1. So y runs from 0 to 1. X runs from y runs from 0 to 1. Y runs from 0 to 1. So this is the integration with respect to x first. So y runs from 0 to 1, x runs from y to 1. And in order to integrate with respect to x, y first, these are the limit. Y runs from 0 to x and x runs from 0 to 1. Okay. So this is the change of integration. Suppose the problem is what? Suppose this is given and we have to change the order of integration, then this is the answer. Or if this is given and the question is change the order, then this is the answer. Okay. So in order to integrate with respect to x, take strip parallel to x-axis, and in order to integrate with respect to y, take strip parallel to y-axis. So this way is AG way. Sketch the region of integration for the integral this, and write an equivalent integral with the order of integration reverse. That is why to reverse the order. That is why to change the order of integration. And in order to change the order of integration, draw the figure. So how you can draw the figure? Sketch the region of the integration. So in order to draw the region of integration, uh, consider this limit of these integrations. So x square to 2x are the limit on y. So what we have? Y is x square. Lower limit y is equal to x square. Y is equal to x square means is the equation of parabola around y axis. So this is the parabola y is equal to x square. So draw this parabola y is equal to x square. Then y is equal to 2x. So y is equal to 2x, draw that line. Y is equal to 2x. Y is equal to 2x, draw that line. Y is equal to 2x. Y is equal to 2x. This is the y is equal to 2x line. This line passes through origin. Y is equal to x is the line which makes an angle 45 with the x-axis and y-axis. That is, divides this quadrant in two equal parts. And y is equal to 2x is above the y is equal to x line. Okay, because its slope is larger than y is equal to x. So this is y is equal to 2x line. Or how we can draw the line y is equal to 2x? Take any 2 points on this line. That is, if we substitute x is 0, then y is 0. Obviously, this line passes through 0, 0. And if x is 1, then y is what? Is 2, 1, 2, or 2, 4. If x is 2, then y is 4. So this is the point of intersection. So y is equal to 2x line, this line. And the point of intersection of these two is what? So solve these two equations. Y is equal to 2x and y is equal to x square. If you solve these two equations, if you substitute y as 2x, then x square minus 2x is equal to 0. Means x in bracket x minus 2 is equal to 0. Means x is 0 or x is 2. And if x is 2, y is 4. So 0, 0 and 2, 4 are the point of intersections. Okay. And so the integration y is equal, and these are the limit on x. X is equal to 0, x is equal to 0, and x is equal to 0 means y-axis, and x is equal to 2 means this line. Line passes through parallel to y-axis and passes through this point 2, 4. Okay, so x is equal to 2 is the line. So integration integration from 0 to 2 x, y is equal to x square to 2x 4x plus z dy dx is equal to. So we have to reverse the order. Write an equivalent integral with the order of integration reverse, or change the order of integration. So this is the answer actually. So here the order is dy dx. Now we have to integrate dx dy with respect to x first, then with respect to y second. So write dx dy 4x plus z as it is, this 4x plus 2 as it is, 4x plus 2 as it is. There is no change in the integrand. That is, there is no change in this function. By reversing the order, or if we change the order of integration, the integrand becomes remains as it is. The integration, the function remains as it is. This function remains as it is. There is no change in the function. So only change in the limit. So what are the limit of x? X, first we write the limit of x. X runs from, suppose there is question mark, and y is equal to, that is question mark. Okay, so x runs from, so in order to integrate with respect to x, first take strip parallel to x axis. Okay, and its one end touches to y is equal to 2x. So find x value of x is y by 2, its lower limit, and the other end of the strip touches to the line y is equal to x square. So from this find the value of x. X is root y, so root y is the upper limit. And in order to cover this area, we have to move this strip from this point to this point. So this point to this point, then this strip, then this area is covered. Okay, so y runs from 0 to 4. So y runs from 0 to 4. So here is the change of here the integrations reverse, order of integration reverse, or the change of order of the integration. And then solve either by using this method, remains as it is, order remains as it is, then we have this answer. We can also reverse the order. Okay, so by remaining order as it is, we have the integration with respect to 4x plus 2, integration with respect to y is 4x plus 2 is constant, so its integration is 4x plus 2 into y, upper limit, lower limit, and then the simplification of this bracket, and then its integration is x cubed by 3, x raised to 4 by 4, x squared by 2, and we have this upper limit, answer is 8. And the limit, to find the limit of integration in the reverse order, we reverse the order, that is we find the integration of this manner, that is with respect to x first. So y by 2 to root y, 0 to 4, then integration with respect to x first, then we have 2x square, integration of x is x square by 2, 4x, x square by 2 is 2x square, plus integration of 2 is 2x, y by 2 to root y, upper limit, lower limit, value at upper limit minus value at lower limit, and then we have the answer of the integration of this quantity is what, y square by 2, and then y raised to half, integration is y raised to half plus 1, that is 3 by 2 divided by 3 by 2, y square by 2, limit integration is y cube by 3, and 3 into 2 6, and then value at the upper limit, that is substitute y as 4, y as 0, we have the 8 answer. We have the both the answers are same, that is evaluate this or evaluate this separately, we have the 8 answer, both the answers are same. Double integration over r, fxy dA, fxy is this, and x runs from 0 to pi, y runs from 0 to 1. So limits are constant, that is integrated with respect to y first or integrated with respect to x first. So here integration with respect to x first is ag, because y into cos x into y, if you integrate with respect to y first, then y and cos x into y both are the functions of y, and now we have to use the part rule. But if you integrate with respect to x first, then y becomes constant, just integrate cos xy, and integration of cos xy is what, x is with respect to x integration first, therefore cos xy means y is constant. So like cos 2x, what is the cos 2x integration? Is cos sin 2x divided by 2, like that. Integration of cos yx is what? Sin yx divided by y. Y is now constant. If there is sin 2x, cos 2x, suppose cos 2x, then integration of cos 2x is what? Sin 2x by 2, like that. Integration of cos yx is what? Cos sin yx divided by y, from 0 to pi. And then upper value at the upper limit, that is substitute x as pi, and then substitute x as 0, sin 0 is 0, so value at the upper limit is 0. And if we substitute y as pi, then we have x as pi, then we have sin pi y, y get cancelled here, so sin pi y, and then integration of sin pi y is minus cos pi y divided by pi, right, divided by pi. Integration of sin pi y is what? Minus cos pi y divided by pi, write that divided by pi. Here is divided by pi is missing, so write divided by pi, and then value at the upper limit minus value at the lower limit, and then we have the answer. And I think it is wrong answer, divided by pi, and then write, then minus 1 by pi is common, and then cos pi minus cos 0, cos pi is minus 1, cos 0 is plus 1, so I think answer is 2 by pi. Answer is 2 by pi. So correction is there. Similarly, the next problem, f of uv, instead of x and y, here u and v are notations, and the over the triangular region cut off from the first quadrant, that is the first quadrant of uv plane, and the line u plus v is equal to 1. So this is the line u plus v is equal to 1, or x plus y is equal to 1. This is the line x plus y is equal to 1. So how we can draw this u plus v is equal to 1 or x plus y is equal to 1 line? uh, the procedure is already discussed. That is, substitute v as 0, then u is 1. So uv, u is 1, 1 0. This is the point 1 0. And if we substitute u as 0, then v is 1. And so 0 1 is this point. And so we have 2 points, draw the line passing through that 2 points. So this is u plus v is equal to 1, or x plus y is equal to 1. Here the notations are just replaced. X and y are replaced by u and v. So consider u as x and v as y and solve the problem. So this is the u plus v, and the coordinate, the triangular region cut off the first quadrant. This is the first quadrant, okay? And we have to integrate integrate f over the region, okay? So we have to integrate this f of uv over this region r. Suppose this shaded region is r, f of uvd. And so integration over r, and f of uv is what? V minus root u dA, and then integrate with respect to either first with respect to v or with respect to u. So in order to integrate, suppose with respect to v first, take strip parallel to v axis. So suppose this is u axis and this is v axis. In order to integrate with respect to v first, here the given is what? Integration with respect to v first, and here the I write here is the integration with respect to u first. Suppose we have to integrate with respect to u first. Integration, we can write after this step two forms. Either write this or write this. So if we have to integrate, suppose with respect to u first, then there is no change in this function v minus root u as it is, and the limit is on the u first. So u runs from what to what, and v runs from to what to what. So take strip parallel to u axis. So this is the strip parallel to u axis, and then its one end touches to the line u is equal to 0. U is equal to 0 is the equation of v axis. So u is equal to 0 is the lower limit, and another end touches to the line u plus v is equal to 1. So from this value of u is 1 minus v. So upper limit is what? U is equal to 1 minus v is the lower limit and upper limit. And in order to cover this tree, this region, we have to move this strip from this point to this point. So and so v runs from 0 to 1. Okay. So if we have to integrate, suppose with respect to v first, then the v, this function as it is, v minus root u as it is. First write dv, then write du, and then v runs from. So draw the strip parallel to v axis now, because we have to integrate with respect to v first, suppose. So its one end touches to v is equal to 0. So v is equal to 0 is the lower limit. V is equal to 0 is the equation of u axis, and another end touches to the line u plus v is equal to 0, and from this value of v is u minus u, 1 minus u. So 1 minus u is upper limit, and u runs. In order to cover this region, we have to move this strip parallel to v axis from this point to this point, and so from 0 to 1, u runs from 0 to 1, u runs from 0 to 1. So either solve this or this, we get the answer. So very simple integration. Integration of v with respect to v is v square by 2, and root u is now constant with respect to v. Root u, its integration is root u into v. Then lower limit, upper limit, value at lower limit, upper limit, then integration with respect to u. And if we find integration through by using this, then we have the answer same, minus 13 by 3030. Okay. So remaining problems we'll discuss in the next lecture.